So now we are ready to take a look at our first problem. This is one-dimensional motion, guys. We're not going to worry about an object that is moving up and down and left and right simultaneously. We'll get to that in short order. For now, one dimension. Imagine an XY coordinate system. This object is only moving back and forth along the x-axis or up and down along the y-axis, but it's not doing both. Only one dimension. So in our first problem, we see that a car starts from rest, accelerates uniformly at 2 meters per second squared for 8 seconds, and we want to know at the end of that 8 seconds what's the velocity of the car and what is the car's displacement. Um, in any physics textbook, you're going to find a problem-solving strategy that is probably more complicated than you care to give a shot. Let's take a look at a little bit simpler problem-solving methodology. The first thing that you would want to do in solving these kinematics. So problem-solving strategy. The first thing that you should do, which we won't need to do in this problem, is make sure that your units are consistent. So make your units consistent. And what I mean by that is you can't have velocity in miles per hour, displacement in meters, and time in seconds. None of that is consistent. Meters per second goes with meters and seconds. Miles per hour goes with miles and hours. So make your time, your velocity, and your displacement consistent. I recommend putting everything in base metric units, which in this problem they already are, so that's not an issue. The second step is to list the variables at hand in the problem. And in this case, there are 5 of them. Those variables being the initial velocity, the final velocity, the acceleration, the elapsed time, and the displacement. So list those. List the variables. We just did that. And read through the problem because some of those variables are given. So when we look at this problem, we see that the car started from rest. That means that its initial velocity is 0. We don't know the final velocity. In fact, that is something that we're asked to solve for. But we do see that its acceleration was 2 meters per second squared and the elapsed time is 8 seconds. And we don't know the displacement. That's what we're asked to solve for in part B. So in part A, we are asked for the velocity, and in part B, we are asked for the displacement. It's probably a good idea to remember that regardless of the ordering in the problem, if it's easier to find part B first, do it. You can always do part A last. You don't have to solve for in the order in which they are requested. So we have listed our variables. Our units are already consistent. We have filled in our given values. So now let's select an equation. And we have 4 equations to choose from. We know that V is V naught plus AT. We know average velocity is V plus V naught over 2. We know that displacement is V naught T plus 1/2 AT squared. And we know v squared is v naught squared plus 2ax. So when we select our equation, it's going to be one of these four, and it needs to meet a couple of criteria. The first one is it obviously needs the variable that you are solving for. It's rather difficult to find velocity in an equation that doesn't have velocity as a variable. So it needs the variable you're solving for. And the other variables in the equation need to be known. So the other variables are known. So using these two criteria, if we want to solve for v, we need an equation that has a v in it. So this last equation has a v. The quadratic does not. This one does, and this one does. So one of those three. So starting at the top of the list, do we know the other variables? Well, we happen to know v naught, a, and t. And this is the variable we're looking for. And look, this equation doesn't even need to be manipulated. It is v, wow, what happened? V is v naught plus at. Substituting our values, we know that the initial velocity is a 0. The acceleration was 2 meters per second squared. The time was 8 seconds. If I'm not mistaken, that's about 16 meters per second. This gives us our velocity. And then to solve for our displacement, any equation that has an x will suffice. That means it's either this equation or this one. Now, we know all of the other variables, so either one of those equations will work. We could take this this equation and manipulate it to solve for x. V squared is v naught squared plus 2ax. V squared minus v naught squared is 2ax. And dividing by the 2a, v squared minus v naught squared over 2a. Now I can substitute these variables into this equation and solve for x. Or I could simply use the quadratic. It's already set up to solve for displacement. So x is v naught t plus a half at squared. V naught was a 0, guys, and I'm pretty certain that 0 times any amount of time is going to be 0. So x is now 1/2 at squared. The acceleration we know was 2, and the time was given as 8, and that one is squared. So that's 1/2 times 2 times 64. If I'm not mistaken, that's about 64 meters. And that gives us our displacement. Now, this problem is solved. I know that the solution is rather large on this page. Let me try to bring this down a little bit. I hope you can see that. So here's the entire solution. Now, if you are in my class and you are solving these one-dimensional kinematics for practice or for homework, I really need to see what I have written here. I want to see where you have listed your variables. I want to see the base equations that you begin with and any manipulation to put them into their proper order. I want to see the values substituted in to said equation, and when you finally get to your answer, put a box around it somewhere so that I don't waste my life searching for that particular solution. So if this were homework, I would be rather pleased because I see that this student knows the base equations. They have followed the problem solving strategy. I see all of the work that they've done, the manipulation, as well as the solution with units. So if you would please pause the video and give this problem a shot. Okay, so the solution to this problem, I will list my variables and fill in the givens. I don't need to make uh, these units consistent. They already are. I have meters and seconds, so meters per second. This is all good. Um, this car is moving with a velocity of 30 but slows to 20 meters per second. So it is, at the beginning of our evaluation, moving with a, let me make this a little more consistent, like the last problem, V naught and V. The initial velocity, V naught, is 30 meters per second. And at the end of our 4-second period, it's moving with a velocity of 20 meters per second. We are asked to find the acceleration for part A and the displacement for part B. So to select an equation, again, these are V is V naught plus AT. The average is V plus V naught over 2. X is V naught T plus half AT squared. And V squared is V naught squared plus 2AX. So select an equation to solve for the acceleration. If I find an equation with A, that looks like equation number 1, equation number 3, and equation number 4. So 1, 3, and 4. So looking at equation 1, here's the acceleration. Do I know V? Yes. Do I know V naught? Yes, I do. Do I know T? Yes, I do. So ding, 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 we have a winner on this first equation. V is V naught plus AT. I will rearrange this equation to solve for acceleration, and I get V minus V naught over T. What do you know? A is delta V over delta T. The final velocity is 20, and the initial velocity is 30, and the elapsed time was 4 seconds. So it looks to me like our acceleration is going to be negative 10 over 4, or negative 2.5 meters per second squared. That takes care of part A, negative 2.5 meters per second squared. And then to solve for x, again, I could use either equation 3 or equation 4, but equation 3 requires no manipulation. So x is V naught T plus a half AT squared. The initial velocity is 30 meters per second. The time is 4 seconds. Plus 1/2. The acceleration we now know is negative 2.5. And the elapsed time is 4. And don't forget that's squared. I'm just going to go ahead and write 16 in here because I'm guessing that that's 4 squared. Okay, yeah, just solve this out, guys. 120, it looks like half of 16 is 8, and 8 times 2.5 is about 20. So minus 20, this looks like 100 meters or so for the displacement.